Hello and welcome to your 15th Algebra 2 class. I am Mr. Marcus, your favorite summer school math teacher, online facilitator. I hope you guys have all been enjoying these interesting last couple of weeks with me fumbling and bumbling and dropping my stuff all over the floor. Anyway, that being said, today we're going to talk about quadratics. Now, since this is a summer course, we are doing a little bit of compression in terms of material. So I'm going to talk to you real quick about how to graph a function using ax squared plus bx plus c and how to solve a quadratic equation by using x squared plus bx plus c method, right? So let's get started. Now, the first thing we want to do is always, first of all, this is not a standard form of a quadratic, or this is maybe one of the standard forms of the quadratic equation, although there are other forms of graphing them. And the first thing you want to do is identify who's A, who's B, and who's C. So we're going to identify this is A, this is B, and this is C. The first thing we want to do is find our vertex. And the vertex is given to us by the formula x equals B over 2A. So what we're going to do is we're going to find the vertex, and we're going to find our axis of symmetry, and we're going to graph that. Now to find our vertex, we simply use this formula in which we're going to say B, which in this case is negative, it's actually negative B minus 2A. So it would be 8, or negative 8, over 2 times 2. So this would be 4 times, or negative, I'm sorry, this would be 8 divided by 4, which equals 2, right? So my axis of symmetry is 2, and we're going to see that a little bit later on, right? Now to find to find my vertex, now to find my axis of symmetry, I'm just going to plug in 2 into the formula. So axis of symmetry is going to be to take what I got from my vertex, which in this case is positive 2, and plug it into my formula to find the y, which would be my axis of symmetry. Now what the axis of symmetry is just assuring that my graph is even, right? That it's not lopsided or anything like that. Or because if it were, then it wouldn't be necessarily in standard form. There would probably be some sort of transformation occurring. Anyway, so we're going to say y equals 2, instead of writing x squared, you say 2 squared minus 8 times 2 plus 6. Okay, so 2 squared is 4, and we'd say, so 2 squared is 4, 4 times 2 is 8, minus 8 times 2, which is 16, plus 6. So 8 minus 16 is negative 8, and negative 8 plus 6, y equals negative 2. So I have my axis of symmetry, which is negative 2. And the last thing I'm going to find is my y-intercept. Now my y-intercept equals c, which in this case it would be 6. And remember that whenever we're looking for our y-intercept, x equals 0, so in reality this is 0 and 6. Now I actually have two ordered pairs that I'm going to be able to graph in my function. So I'm going to draw my coordinate plane, and my first ordered pair is actually positive 2, which was my axis of my vertex, and negative 2, which was my axis of symmetry. So go ahead and graph positive 2 and negative 2, which is down here. And then my other coordinate is 0, 6, which is my y-intercept. So 1, 2, 3, 4, 5, 6. Now, a quadratic function, you all know, is a parabola, meaning that if a is greater than 0, it opens upward, and if a is less than 0, it opens downward. So in this case, because a is 2, it's positive, it opens upward, so I know that my graph is going to kind of look like this. Now, there are various methods of finding the other coordinates, like a reflection, for example, reflection across the y-axis, in which the y-coordinates stay the same, but the x change. So if I have 0, 6, which is right here, the reflection of that, now I remember that the graph has to be symmetrical, and my axis of symmetry is actually negative 2. So what I'm going to do is actually count, or more or less look at where my graph would be symmetrical. Now my graph would be symmetrical at about here. So technically, 4 and 6 is my other point. Why 4 and 6? Because again, I have 0 and 6 here, and I want to make sure it looks symmetrical. So my symmetry is, or my axis of symmetry is -2, so actually what I did was I counted 2 spaces and more or less figured out where this looks symmetrical, and it looks symmetrical at about 4. Now when I did the first curve, I noticed that when I went from 0.6 to 2 and -2, I passed through 1, 0. So my other point would be the reflection of 1 and 0. So the reflection of 1 and 0 is actually 3 and 0, which is about here, which means that when I graph my function and I complete everything, this is what my graph looks like, more or less, of course. Now another way of determining that is very simple. So that's one way of doing it. Now another way that you can do is if I have my 0, 6 and if I have my 2 and -2, and I want to make sure that I am changing, right, my x-axis, what I do is, because 2 and -2 is my axis of symmetry, I can just take and my axis of symmetry is 2 and -2, so I can just kind of move 2 spaces to the right, which is where I got my 4 and 6 from. And then another way of determining the 1, 0 is by plugging, since when I graph the function, it passes through 1, 0, I can just plug in 1 here, and that would be a way of finding my other reflected point, which would be 3, 0. Okay, so all you really, once again, to recap, all you have to do is look for the vertex, look for the axis of symmetry, which in this case is 2 and -2, and my y-intercept, which is 0 and 6. Draw half a curve. Because my axis of symmetry is at -2, I'm going to count 2, and I notice that my graph is moving to the right because this is positive. Then I just kind of count from this point 2 spaces to the right, and I understand, or from my vertex, I count 2 spaces to the right, and that's where I get the 4 from. Okay, so again, 0 and 6 is what I got from my axis, from my y-intercepts. 2 and -2 is what I got from my axis of symmetry. So I know that this is where the graph is going to be kind of cut in half. So what another way I can do is draw an imaginary line. And I want to more or less reflect the 0, 6, since my axis of symmetry is 2 and -2. I can just kind of look to the other side and see more or less where my other point is going to be, and that's where I get the 4, 6. When I draw my curve, I actually go through the 1, 0 point, and again, 1, 0 is here, so the reflection of 1, 0, which would be after the axis of symmetry, is 3, 0. Okay? So again, I know it's sounding redundant. I just want to make sure that I'm explaining myself correctly and you understand it. This is my original problem. All I did was I found my axis or my vertex, excuse me, using the formula x equals b over -2, or negative b over 2a. Negative b would be -8, which turns into +8. Of course, 2 is part of the formula. A is also 2, so 2 times 2 is 4. 8 divided by 4 is 2. What I did was I plugged in the 2 into my formula, and that gave me -2. So I actually have an ordered pair, or my axis of symmetry is actually at 2 and -2. And what the axis of symmetry means is that it's the point in which the graph is divided into 2 equal halves. After that, I look for my y-intercept, which is 0 and 6. So I have 0, 6, and 2 and 2. Now, since my axis of symmetry is at 2 and -2, I draw that dotted line that helps me separate the graph into 2 equal halves. And I know that 0, 6 is here, so I want to see where it would exactly be reflected, and I know that would be about here, and that's the coordinate 4 and 6. When I draw my curve, I realize that when I go from 0, 6 all the way to the axis of symmetry, which is 2 and -2, I actually pass through point 1, 0. So I want to go ahead and to make sure that my graph is symmetrical, I reflect 1 and 0. So 1 and 0 is here, and the reflection would be about 2 more spaces, which is 3, 0. And that's how you draw that, okay? So I'm going to go ahead and step out of the camera, make sure that I have no technical issues, and then we're going to continue to solve the equation. Everything seems to be in order, so I'm going to go ahead and erase this, and I'm going to go into solving the quadratic equation. Now, there are equations quadratic equations, just like there are linear equations, just like there are rational equations, just like there are trigonometric equations and logarithmic and exponential equations, there are also quadratic equations. It's just that we have different methods of solving them. Now, one of the methods utilized to solve quadratic equations is x squared plus bx plus c equals 0. And that's just a method used to solve a quadratic equation where the leading coefficient is 1. Now, if I look at x squared minus 13x plus 48 equals 0, I want to solve that by factoring out this polynomial. Now, or this trinomial. Now, the way I factor that out, whenever my leading coefficient is 1, is by looking at the 48 and the 13. And think of two numbers that when I multiply equal, and there's a mistake here, it's supposed to be equal positive 13 and negative 48. Okay, positive 13. So two numbers that when I multiply equal negative 48, but when I add equal positive 13. Now, the only two numbers that come to mind are x plus 16, excuse me, and x minus 3. Now, 16 minus 3 is 13, and 16 times negative 3 is negative 48, and all that equals 0. Now, what I'm going to do now is simply solve each equation individually, or equal each term to 0. So I'm going to say x plus 16 equals 0, and x minus 3 equals 0. So I'm going to solve for x by, in this case, subtracting 16, and on one side I have x equals negative 16, and I do the same thing here, I add 3, and on the other side I have x equals 3, and those are my two answers. Now, I can't check my answer, and in fact I'm just going to say, I just check my answer twice. One for x is negative 16 and one for x is 3. So I'm going to say, actually I'm going to plug in negative 16 here, negative 16 plus 16 times 16 minus 3 equals 0. This is 0, and this is times 3, which equals 0. So I know that's correct. Now I'm going to do the same thing here, and I'm going to say, well, 3 plus 16 times 3 minus 3. 3 plus 16 is 19, and 3 minus 3 is 0, and of course that equals 0, so they both check out, which means that this is correct. Now, that's pretty much how you work on those equations. I did assign some practice problems along with this video. So, we're almost done, down the home inning stretch. Stay safe, and I hope to see you soon. Bye-bye.